Dr. Luis Arroyo is a researcher at the Ontario Veterinary College, and today he's going to talk about an upcoming research project where his team will be screening for biomarkers as indicators of intestinal health among equine microbiota. Welcome, Dr. Arroyo, and thank you for joining us.
Hello, Jackie. Thank you for the opportunity to talk about this new exciting initiative. This is another joint collaboration with my friend and research partner, Dr. Marcio Costa at the University of Montreal.
First of all, what are biomarkers and why are we interested in them?
Yes, that's a great question. Basically, a biomarker is a biological molecule that you can find in different places. For example, you might find this in blood, you might find this in urine, you might find that in tissue or different fluids, body fluids. And that is a sign of normal or abnormal processes going on, or maybe a marker of a disease. A biomarker can be used to see, for example, how well the body might respond to a treatment or to disease condition. And these biomarkers, they're also called signature molecules. So there might be an indication of inflammation. There might be indication that the disease is improving with treatment, or might be an indication that things are getting worse. So the changes in the intestinal microbiota, for example, that we call dysbiosis in terms of disease, um, those can be found uh, in many disease processes, and a biomarker might give us an indication that even though we don't see it yet clinically, but that's an early indicative that those disease processes are beginning to take place or already occurring in the system.
What do we know so far through next generation sequencing of DNA about healthy and undesirable inhabitants of the equine gut?
Yes, well, this technology has been already with us for a while, and it has been really great at letting us determine changes in the bacterial populations and the proportions that occur in a particular disease process, or how do they behave in a normal, healthy individual or animal. And with that information now, we can target changes to either diagnose or as a therapeutic processes. For example, if we have a dysbiosis process going on, we can look for specific markers or specific taxa of bacteria that might indicate that that is going on. So with that, for example, an increase on gram-negative bacteria like the Enterobacteriaceae, or decrease in some other bacteria like Nospiraceae, I commonly observe in intestinal inflammation. Now we can use that information to uh, already show that these changes are taking place, and we can either change, for example, the treatment plan that an animal is on, or we can modify it, or perhaps we can in the future have some therapeutic interventions to prevent that dysbiosis from developing or for getting worse.
This new research project proposes the use of PCR testing as a potential economical test to discover equine gut issues early on. Now, we've all become aware of PCR testing because of nasal swabs that we've had to use in rapid tests for COVID-19. How may PCR testing work to check for signs of health and disease in the equine gut?
Well, that's a great question because as we all familiar with PCR, like any other test or rapid test or lab test that we submit to a particular diagnostic lab, this would be the equivalent of a bedside test, really, in horses, where an animal can be tested for signs of dysbiosis. And if that is the case, those animals are candidates for changes on the medical management, or perhaps, as I mentioned earlier, therapeutic interventions to correct the dysbiosis. At this time, we have a student that is working in these projects, which already identified 10 different bacterial taxa that are consistently found to be modified or altered in horses with some sort of intestinal disease or while treated with antibiotics. So those different taxa now we can target with PCR and check to see if there will be good indications or markers of dysbiosis. Instead of doing sequencing of all the bacteria in there, we will only target a small number of them, which will give it a very good and reliable indication of what's going on in these particular cases.
When will this project begin and what are the challenges anticipated in this upcoming research?
Well, the project per se already began by doing some literature review and looking for some information in other animals and looking at some of the pathways, softwares, and why not that we might be using. But the project per se will start in this summer. And again, as I mentioned earlier, this is a jointly supervised graduate student from St. Hyacinthe, University of Montreal, who will start optimizing and performing PCR testing on samples that had been collected from clinical cases and healthy controls, throughout the years. And we have a biobank of such samples that we can start to test right away. Challenges will be, of course, part of the optimization process will be a big challenge. We have to make sure that our results are reliable, that what we're amplifying is the true thing. So we need to send those samples for testing. The sample population should be homogeneous, so that might be also a challenge, getting samples that all fit within the same category. So horses, for example, with undifferentiated colitis, so horses that are perhaps salmonella infected, or all horses that have been with a particular antibiotic. So those are big challenges. And then analyzing the data and the softwares, to make it user friendly. Those will be there will be undoubtedly uh, challenges that we'll have to overcome.
How will your study seek to overcome these challenges?
Well, I think we will basically we will adhere to rigorous molecular techniques standards to optimize our results, and we will make sure that we will check in every step of the way the results that we are testing and ensure that our data is reliable. And we will also make sure that the sample size that we're using will be representative of what is going on in a larger population. And we will consult extensively if we need to, particularly with complicated or advanced softwares that we might need to use to analyze our data. But we will hoping that this ultimately will turn into a simple test that can be user friendly and it will be clinically applicable.
Thank you, Dr. Arroyo. We look forward to following this research.
Thank you, Jackie. It's great to see you, and I look forward also to reporting this research. And I thank you, EQUINE, well, for the funding and the continued support in this gastrointestinal research that we carry out here at OVC.